Hello students, welcome to our physics class. In this class, I am going to discuss about the first very important derivation in electric charge and electric field. So this is the first very important derivation in this chapter. Okay, well, let's start today's class. Derivation of expression for electric intensity at a point on axial line, a point on axis of electric dipole. This is the first very important derivation in electric charge and electric field. Okay, first here let us consider an electric dipole. What is the meaning of electric dipole? A pair of equal and opposite point charges separated by a small vector distance. That is the meaning of electric dipole. Pair of equal and opposite point charges separated by a small vector distance. The line joining the two charges is called dipole axis. It is directed from negative charge to positive charge. Actually, this is the dipole axis. So minus q here located at the point A plus q located at the point B. So 2a is the vector distance. 2a is the vector distance and it is directed from negative charge to positive charge. So a line passing through the dipole axis is called the axial line. What is the meaning of axial line? This is axial line. Axial line is a line passing through the dipole axis. It's called the axial line. So P is here the observation point. So that is a point lie on the axial line. Actually, this position is called the end on position. So at point P, we have to calculate the resultant electric intensity that is produced by electric dipole. Okay, the distance from the observation point P to the center of the electric dipole, that is R. What is the meaning of R? R is a distance from the observation point P to the center of the electric dipole. So what is the distance from P to B? So P to B is R minus A, and the distance from P to A is R plus A, because PA is PO, PO plus OA, PO is R, OA is A, even OB is also A, right? So R is the distance from observation point to midpoint of the electric dipole. Okay, so how many electric fields are there at the observation point P? And this is very, very important. So how do you find out the electric intensity at that point? So by using a test charge. So what is the meaning of electric intensity at a point? Electric intensity at a point means the force experienced by a unit positive test charge placed at that point under observation or consideration. So actually at the point P here there are two electric intensities. So one is produced by minus q point charge at A, and another one is due to a plus q that is located at point B. So actually, while calculating one electric intensity, we just ignore the presence of other point charge. So plus q naught is placed at the observation point P due to minus q. What happens? Due to minus q, plus q naught will experiences attractive force, right? So that is why the direction of electric intensity at point P due to minus q at A, that is along PO. So it is directed towards the center of the electric dipole. And while calculating this electric intensity, that is electric intensity at point P due to minus q at A, we just ignore the presence of plus q at point B. Okay, and one more electric intensity is also there at point P due to plus q at B. So that is along OP direction, right? So plus q naught is placed at the observation point P due to plus q. What happens? The plus q naught will experiences the repulsive force. It is directed away from the center of the electric dipole. That is EB vector. EB vector is directed along OP. EA vector is directed along PO. So these two arrow marks are very, very important. The electric intensity at point P due to minus Q at A, that is along PO, because plus Q naught will experiences attractive force due to minus Q, and EB vector, that is along OP direction. Why? Because plus Q naught is placed at point P due to plus Q naught will experiences repulsive force. EB vector means electric intensity at point P due to plus Q at B. EA vector means electric intensity at point P due to minus Q at A. Okay. So let's start the derivation. First, here let us consider P is equal to Q dot 2A. What is this? Electric dipole moment. P is equal to Q dot 2A. This is electric dipole moment. What is the meaning of electric dipole moment? So electric dipole moment means the product of magnitude of one of the charge and the dipole length. Okay. So the electric intensity at the point P due to a charge plus Q, that is at B, is E A, that is E B vector. So electric intensity at a point due to isolated point charge expression. So by using expression for electric intensity at a point due to point charge, that is E is equal to 1 divided by 4 pi epsilon naught Q divided by R square. R is the distance from observation point to point charge. So here electric intensity at point P due to plus Q at B is EB vector. So EB vector is equal to 1 divided by 4 pi epsilon naught Q divided by, what is the distance from observation point to point charge? That is R minus A. That is why Q divided by R minus A whole square. And this is along which direction? That is very important. So electric intensity at point P due to plus Q at B, that is along OP direction, right? That is directed away from the center of the electric dipole. So the magnitude of EB vector is EB, and this value is 1 divided by 4 pi epsilon naught q divided by or minus a whole square. So call this as equation number 1. So after that, let us calculate electric intensity at P. So due to minus Q at A, that is E A vector is equal to 1 divided by 4 pi epsilon naught Q divided by, so electric intensity at point P is due to minus Q. Now minus Q is the point charge, so P is the observation point. The distance from observation point P to point charge, that is R plus A, Q divided by R plus A whole square. And this is along which direction? That is along PO. It is directed towards the center of electric dipole. Plus Q naught is placed at the observation point P. Due to minus Q, what happens? Plus Q naught will experience attractive force. It is directed towards the center of the electric dipole. This is along PO direction. And the magnitude of EA vector, the magnitude of EA vector is EA. So EA is equal to 1 divided by 4 pi epsilon naught Q divided by R plus A whole square. Okay, so call this as equation number 2. So now comparing the two equations, that is 1 and 2. What is your conclusion? That is very, very important. So from equations 1 and 2, so we can conclude that the magnitude of EB vector, that is much greater as compared to the magnitude of EA vector, right? So if two actors acting at the same point but in opposite direction, so what is the resultant? The resultant is or is equal to P minus Q. So if two actors moving in the same direction, so resultant is P plus Q. So moving in opposite direction, that is P minus Q or Q minus P. That depends on the magnitude of two vectors. Actually here the magnitude of EB vector is much greater as compared to the magnitude of EA vector. So that is why the resultant is EB minus EA, right? So the resultant electric intensity at point P, the resultant electric intensity at point P, that is E is equal to EB minus EA. What is the value of EB? EB is 1 divided by 4 pi epsilon naught Q divided by R minus A whole square. So E is 1 divided by 4 pi epsilon naught Q divided by R plus A whole square. So here Q divided by 4 pi epsilon naught, that is just take it as outside. So here what is the remaining? So Q divided by 4 pi epsilon naught, that is taken as common. The remaining is 1 divided by or minus a whole square. Minus here, what is the remaining? Remaining is 1 divided by or plus a whole square. Okay. So here, what is the LCM? E is equal to Q divided by 4 pi epsilon naught. The LCM is or minus a whole square into or plus a whole square. So here or minus a whole square get cancelled. The remaining is or plus a whole square. And here or plus a whole square get cancelled. The remaining is or minus a whole square. This is very simple calculations. E is equal to Q divided by 4 pi epsilon naught. So or minus a whole square or plus a whole square. So this can be written in the form of or minus a into or plus a. Again or minus a into or plus a, right? So or minus a into or plus a, that is or square minus a square. Again or minus a into or plus a, or square minus a square. So or square minus a square whole square. This is the LCM, right? Or square minus a square whole square. So or plus a whole square is or square plus a square plus 2 or a, so minus of or minus a whole square is or square plus a square minus 2 or a. Okay, so after that E is equal to Q divided by 4 pi epsilon naught. So actually here or square get cancels, a square get cancels. So minus is taken as inside. What happens? Minus or square minus a square plus 2ra. So or square minus or square plus or square minus a square plus a square get cancels. So remaining is 2ra plus 2ra. So that can be written in the form of 2 into 2ra divided by r square minus a square whole square. So E is equal to 1 divided by 4 pi epsilon naught. So Q into 2 into A. So Q to A. What is this? Electric electric dipole moment. P is equal to Q dot to A. That is 2 P R. P is Q into 2A. So divided by R square minus A square whole square. So this is the mathematical expression for electric intensity at a point on the axial line. And this is a very important mathematical expression. Okay, what is this? Expression for electric intensity at a point on the axial line. But for a short electric dipole, or is much greater compared to A, so then A square, this is negligible, or is much greater as compared to A square is negligible. So then the above equation becomes E is equal to 1 divided by 4 pi epsilon naught. So 2 PR divided by, so A square is negligible, R square whole square is r power 4. Finally, E is equal to 1 divided by 4 pi epsilon naught 2p. So r divided by r power 4 is r cube. This is the mathematical expression for electric intensity at a point on the axial line, that is for a short electric dipole. Okay, suppose if the point P lies far away from the center of the electric dipole, or is much greater as compared to A, then A square is negligible, and this is the expression for electric intensity at a point on the axial line. That is for short electric dipole. So P is electric dipole moment, so R is the distance from observation point P to center of the electric dipole. Okay, thank you. This is the first very, very important 5 mark derivation.